Welcome to stream number 47 in this series where I'm programming an NES game live on Twitch. Last time we finished the code that I was working on that updated the way we were writing out our metatiles so that it was doing the calculation of what metatiles were loaded in the game loop, and then the only thing it was doing in the NMI was actually just loading those tiles in directly. So that got us tiles that actually have proper colors now loading in, and we're not getting any weird sort of behaviors in terms of you know, like weird stutters or anything. So it's working as expected, which is cool. And what we said we needed to do for the next stream was start looking at how we're going to do collision detection, and also probably want to look at things like how we can make this a little bit smarter, but I'm not even sure. I'm not sure I want to do that right now because we spent a lot of time, a number of streams working on getting this all to work. So maybe we'll focus on something a little bit different for these streams, and then we'll come back. So what I'd like to be able to do is make it so that we have... actually, I'm curious to know if I were to... I didn't try this yet. Let's try, just for fun, exporting this out and seeing what happens. But I'd like to be able to get to a point where we can start having collisions with the background. Some real artwork would be nice too, but that's not something I'm going to do on stream just because, well, I don't know that people need to see me sitting here putting pixels into Photoshop or whatever to make some basic, really awful tile art, because I'm not an artist. So let's see. So here's map 1. That looks good. Let's export the project, and then we have to copy all this stuff over. Now at some point we'll probably be good enough with what we have here to feel like the asset tool and the assets themselves can actually live in this shooter folder here, but for now, because it's still kind of all in development, we're just kind of letting it hang out in the asset tool folder. Sweet. So that worked without any changes or anything. That's perfect. That's exactly what it's supposed to do. We've got these tiles, and it's using the palette, and that all looks good. And we have our sprite. And I did check this on a real NES after the last stream, and got the expected results, which means that we're using the mapper correctly, which is cool too. So at this point, we really have to figure out how do we want to handle collision with these metatiles. So the first thing that we talked about in one of the streams was the fact that we want to have sort of a broad collision capability where you can say, okay, this metatile has no collision, so don't even bother checking at the subtile level. And then we need to be able to, for the tiles themselves, add appropriate collision. So let's see. So like if we take the green tile, let's see. So this has something called a collision editor, but it looks like it to me is a little bit too fine-grained. And what I mean by that is that it's at a pixel level, and I don't know that I want to do that. I think I want to do just at a tile level. So, you know, these tiles are metatiles are 4x4 regular tiles. What I really want to be able to do is in either here or the asset tool, mark off the individual tile in the metatile that is collidable. So I'm wondering if what I need to do is have some sort of grid that gets drawn on top so that we can see, make that be maybe toggleable, and then from there we can click on the individual tiles and make them collidable within the metatile. I'm not sure how that maps into the map here. Like, I don't know that we'll ever see that in this, which I'm not crazy about. It's just that I feel like this is too arbitrary, right? Because you can do this, and then I assume that if I reopen that, it will, let's see. No, it doesn't really, doesn't seem to care about that. But obviously in the tile itself, if we export that, although I don't think we don't really care about those because we're just using the PNG for it. So that would be another approach. That would be yet another thing that would kind of complicate what's going on. I mean, so maybe what we would do is that we would, in the map itself, we would be able to see those collision points. Well, so let's start with, in the asset tool, let's update the definition of the meta tile. So right now it's got the palette and it's got the image. And what I want to do is I want to add something called collidable, or has collision, and then let's see, that's the image. So just hard code that to 16 because it's 4x4. Although I don't know that it needs full byte. We could encode that a little bit more intelligently and use 2 bytes per row and 4 rows, so 8 bytes. And just have a bit represent that. Hey, Vashtarak. I don't know. I guess that seems okay. I mean, it's not crazy about it, I'll be honest, but I'm not 100% sure how I want to handle that. Let's so alright, so that's this sprite to image, metatile to image, load map. So save metatile, let's see. This is where it's going to recreate that. That's the image, and so what we can do is we can say current metatile has collision equals 0. Well, actually, that's all properly initialized in the mem set, so we just rewrite our metatile objects so that they're complete. Oh, I've got the asset tool open. So gradient. Okay, that's good. And then I don't know why it's doing that, but okay. None of those are the color. It's weird. And then where's blue tile? Blue tile. Blue tile. Okay, so if we re-export all of that, nothing should have changed or broken. Let's see, so all of that stuff again. Alright, so the green is a different color, but it's okay. I had messed around with the color in the green tile, so that's looking fine now. Alright, so we've rewritten the metatile objects with the collision info now. So the question is, well, I guess a couple of things. Let's add the toggle for the grid. So let's add oops. So we'll add this draw grid toggle, and let's see, if draw grid where's it drawing the metatile? Draw a metatile there. So we'll do and then current image. So we know this is a metatile. 0 y is less than 4. X y x y plus for drawing the metatile, I forget what scale it uses. Oh, wait a minute. Wrong spot. All right, so X will be the same. So we're just going through. Actually, wait, do I need to do it this way? So I'm just drawing a grid. I just want to draw the horizontal and then the so X is what's changing, and X is going to be times 8. And Y is 0, and then current image, yeah. And then we need to do the reverse. So I think I'm missing a parameter. I added predefined colors. Did I not? Current image, X, Y, X, Y, oops. Let's see if I got that right. Nope. All right, let's see if this is even toggling. It is. Current image. Oh, you know what? The problem is that it's drawing the image scaled, but the metatile is not scaled here. So we're going to add the ability to draw the grid here. And then let's go modify this. So let's see, tiger free, display image, get resized image, else this. So when it comes to render image, okay, so what we need to do is add something for image data so that it can store whether or not it should be drawing the grid. And this should always be happening. So node draw grid equals draw grid. Oops, image data. So that'll tell it whether or not it needs to draw the grid. And then we have this, so that draws the image, and then I cleared that out of my buffer here. There we go. Get that back, just so I don't have to re-implement this. Let me just draw that on the layer that gets passed in, and then we actually don't have to do the multiply for the width and the height because that's fixed. The layer is the size that it is. Image data. Okay. Let's see if that works. Oh, well. Yeah, I guess that doesn't work exactly right because that's drawing that on. Bleh. It's annoying. All right, so we have to offset it based on the position because the layer is the background layer that it's drawing onto. So that's that, and then this is drawing it onto the layer, and this is node X, this is node Y, plus Y shifted by 3, and, oh, except that it's not, then that's not the layer height, that's node image data display image height. Node. All right, so that's X, that's Y, that's node X plus this. The the autocomplete is really wacky. The way it's like cutting out things from other statements that I'm adding to here. So let's see, and toggle grid, and then all right. So. Oh, except that it's not, of course it's not 3 because we're also multiplying that by, so it's really, because we're scaling it. And then the reason that it's not drawing immediately on hitting that button is because I'm not telling it to refresh. So, all right, let's fix that. But that's looking like what I wanted it to look like. So draw grid, image changed. Let's see, draw grid, image changed equals true, so that it refreshes. And then if we select an image, we need to turn this off. Okay. So we have that, and then toggle. Weird. Why isn't that? Oh, damn it. I didn't want to do that. I wonder why that's not... changed equals true. Should make it redraw. Button export. Is it because it's... Oh no, that would be... Oh, you know what it is? It's because this is happening before we render the image into the buffer. So let's go up here. And now, there we go. So now we get our grid. That's showing us our 4x4 tiles. Now the idea is that we should be able to just toggle by clicking in there if it's collidable. And then from there we'll save that, and then we'll load that back up and mask the image appropriately depending on whether or not it's collidable. So I want to move that toggle grid button down. Not that that's super important, but it's just bothering me that it's so high up there. Yeah, that's better. All right, so let's see. right now, image, I don't remember if we have it returning anything. We don't, because it didn't care about whether or not it was clicked. So let's see. So now what we should do is we should return back if it was clicked. Remember if I have I didn't think I had something like that. Do I have a vector 2? I don't remember. It's been a while since we've worked in here, so I know that breaks everything. Just don't you worry about that. If not vector, no, if not selected, selection. So obviously if selection isn't passed in, then we don't really care if anything was clicked, right? Because we're not going to do anything about it. Because then we can't pass the information back. If it is, then we will figure out where it was clicked. So how do you do that again? It's Tiger Mouse. Tiger Mouse. Layer MX, MY, MB. And then let me think about this. I think if I remember right, what we did in previous things is we checked to see if it's within, yeah. So I should put my phone away because it's distracting me. All right, so if MX is greater than node X and MX is less than node X plus node width. If MX is greater, MY is greater than node Y and MY is less than node Y plus node height. Oh, stop it, autocomplete. You're really going to give me a hard time about that? All right. So if that's all true, then we say mx minus equals node x, my minus equal node y, selection x, x equals mx, selection y equals my, return true. And then let's see if this is working now. So I want these values to, oh, this is, they're shorts. I want the values to be within the range of the image, not the range of the screen. So okay, so that is looking good. I just need to have it only return if true if it's if it's clicked. So if MB and 1 doesn't equal 0, well, actually, you know what? We can check that first. If MB and 1 doesn't equal 0, right? No point in checking to see if we're inside that range if the left button wasn't clicked. Okay, and then the only other thing we need to do is have a previous state, and node button equals 0, node button equals 1. So we only want this to trigger after a full click and release. Actually, that's not exactly right. If node button equals 0, this, else node button equals 0 equals 1, and return false. Why isn't it resetting it? Oh. Else node button equals 0. Okay. Cool. So that tells us where inside there it clicked, which is what we want, because then I want to be able to toggle the grid and toggle a mask on this. Okay. So now what we need to do is we need to scale this to the appropriate scale for the metatiles. So we know what we actually want to do here is we want to say if metatile selected and right, because we don't care about the click if it's just an image, at least in theory right now. Same thing with the sprites. We might later, but I don't want to see so the compiler short-circuited the logic here and didn't bother calling that because metatile selected was false. So I'm going to reverse the order so that it calls the ImageDraw first, which is what we want. So that click works. That click does not. That's good. That click does not. That does not. That does not. Okay, good. But this one will. Excellent. Then we can toggle the grid. Cool. So now that we have that working, what we want to do is, we know that this is 32 by 32, and it's been multiplied by 4. So what is that, 128? Is that right? Yep. So let's just divide that by 128 to find out which, no, we can, divide by 128 is what, shifted to the right 7? Yep, that's what I thought. But I always like to check these things because sometimes, you know, my brain, it just does stupid things, and then we waste time trying to figure out something that should have worked. So we can see by clicking through now, our grid is progressing as expected. So we've got our 3 by 3 coordinates now, or 4 by 4, but index 0 to 3. So that's good. And now what we want to do is we want to say, okay, if we're in here, then we need to modify the metatile selected. Sorry, the metatile collision. So let's see. So what is it? Is it selected metatile? I don't know. Current metatile. Collision. So we know the X and Y position, and we know that this is I don't know why I have that open. We've got our 2 bytes that represent the 16 here, right? Because wait, no, one. Did I mess that up? I said 8 bytes, right? Because 4 bits, 4 bits, 4 bits, 4 bits. That should really be. It's 4. It's a 4 by 4, right? Yeah, that only needs 2 bytes. Not, I don't know why. It's 16 total tiles. So 4 bits by 4 rows of 4 bits. That's 16 bits, which is 2 bytes. I must have just done the math wrong, or confused myself or something. Doesn't matter. So it's 2 bytes. So what we need to do is we're gonna have to rewrite those out, but that's okay. That only took a moment. So now we have our Y and our X, but those are the shift values essentially. So what we want to do is we want to say, well, actually, if we're going to do that, if it's only 2 bytes, this is, I'm making it even harder for myself than it needs to be. It's just a short. And then what we can do is we can say collision or equals 1 shifted y times 4 plus x, right? So, or selection y, selection x. So if it's, if x is 0 and y is 0, it will be shifted no times, so the value will be 1. If x is 1 and y is 0, then we're going to get 1 shift. X is 2, we'll get 2 shifts, 3 shifts. Then when x is 0 here, y will be times 4, which is really just a shift 2, right? So we'll take that, multiply that by 4, so we'll get 4 shifts, because we're really talking about, we have a 16-bit value that represents now all of our collisions for the metatile. We're just kind of shifting it across. And we're doing it in a slightly different way, right? Like visually, you're starting from the top left to the bottom right. But in terms of bits, you're starting least significant bit and going to the most significant bit. So and then it's really, the other thing is we're toggling it. So it's exclusive OR. And so what we can do after that is we can write the hex value of this and see how that changes and make sure that that's looking right. So what the XOR will do is it'll flip the bit back and forth depending on how many times you click it. So if we look at .80 in hex, you can see that that last bit is set, which is, why would it have done that? Oh. I have to actually store that change and not just display it. Can't you do that? Selection, or is it shift equals? There we go. And then we'll just display the shifted value. Yeah, stop debugging. Stop it. I know S can't go there. Metatile, toggle grid. Okay, cool. So you can see it's going back and forth between 1 and 0, and then it should be 2 and 0, and then it should be 4 and 0, and 8 and 0, and then 1 0 and 0, yeah, 2 0, 3 0. Sorry, 4 0. I'm counting bits, but 8 0, and then 1 0 0. 2 0 0, 4 0 0, 8 0 0, 1, yeah, 2, 4, 8. Uh-oh, let's see. Oh, is that really? That's weird. I wonder if that's something with printf. Let's do this. It's only 16 bits, so that's the only value it should have. It's probably what I think is happening is printf is assuming it's 32 bits, and it's getting the upper bits that aren't actually being used by that short, and messing up our display. Yeah. So now what's cool is that we can just check, so we can say like, okay, if the whole thing, and obviously we need some sort of visual representation of this, if the whole thing is collidable, all the bits are set, right? Because every one of the bits in the 2 bytes, like, that's kind of the nice thing about the way this is worked out, is that this top part is the lower, this right 2 digits of hex, and this part is the upper or left 2 digits of hex, and then as you toggle through, it changes the hex value accordingly, and we are selectively toggling on individual collision bits. And then the other part that's nice about this is we just say if current metatile collision equals 0, then has collision equals, well, actually, we just do this. There we go. So we set the collision based on whether or not the collision bits are set. So if there are collision bits set, it's not going to be 0, which means that it has collision. Otherwise, we know it doesn't have collision, right? Just to kind of further emphasize that, we can print that value. So we can see that while the bits are set, it says we have collision. Let's see what bits are set now. I was randomly clicking, and then so these 2 bits are set, and then these 2 bits are set, and then that bit is set, and then that bit is set. Almost F0. F0. Oh, that hole. There we go. And so as soon as I untoggled that last bit, the first value in this print here that it has collision became 0. So that's an easy way that we're representing that. Okay. So now that's good. Let's actually, I should have left the asset tool open. Let's resave our metatiles to represent the right now we had changed the way that the metatile collision information was saved, so we want to resave that. Green tile, create metatile. So green, click, switch, save. Can actually make that darker. Okay, and then blue tile, I think we did. No, maybe not. Create save, and then gradient, create, and save. Okay, so now that's working. And then the only other thing I want to test is we should be able to toggle the grid and enable one whole row of collision and save that. And then if we come back to it and let's see, we come back to it and we go back to the grid view and yep. And so our collision information was saved when we saved the metatile, which is good. So that's excellent. That's working. So now we just need a visual indicator that the collision has been toggled. I probably only want to do that when the grid mode is on. It'd be cool to have a shortcut key for that too, although it's not really important for now. But let's get the visual indicator going here. All right, so if current metatile has collision and draw grid. We've already drawn the image, and so now what I want to do is I want to draw rectangles that are translucent, and I want to do that over the image. So right now we don't have any way of doing that. So let's add it. We haven't added anything to the way the GUI works in a while. Let's do that, if I remember how. No, it's not that hard. So I don't care about selection, so we'll say rectangle, our ID, our X, our Y, our width, our height. No image. What we want is what is it? Is it a Tiger RGB? Color. And T-pixel. And then opacity, and I'll make that a double. I'm thinking we could probably, I don't remember is there a background color? There is a background color, so realistically the only thing we need to save is the opacity, which probably could be part of the node. The reason I'm using, it doesn't even really need to be a double, it could be a float. The reason I'm using that is I'm just saying, you know, it's going to be from 0 to 1, where 1 is opaque and 0 is totally transparent. All right, so control node times pointer, find set active current context ID. So let's find the node if it's there already in our rendering tree. If it's not, we're going to initialize a control node. The background color is color. We have the X, the Y, the width, the height, and there is no anchor style. And then opacity will be opacity. And that's it, I guess. Right, there's really not much more that needs to happen other than render rectangle. So we gotta actually draw that. So that gets called by our render call here. Now I don't remember. Takes T pixel. That does allow for alpha. So what we'll do is we'll do layer node X, node Y, node width, node height, node background. So actually, we don't even need a separate opacity, really, because that's already part of node background alpha equals opacity. Let's see, and that is an unsigned character, so multiply that by 255, and that will give us our alpha, because it's doing it from 0 to 255 instead of a float, which is fine. Just cast this. What is the problem? Oh, it doesn't like. It's just warning me about that. All right, so let's see. So what we can do just to check this is if, again, just really, this is just for testing. We'll clean this up in a section in a second. Collision 1. We'll say GUI image. No, not image. Rect image ID +1. Current, well, 180, 20. It's 32 times 16. What did I say that is? That's the width, but it's 8 times 16, which is no. That's 60. They're 4 by 4. That's the whole image, which is 32 by 32, right? Times 16. So that's the whole thing is 512. Did I have that right? I guess I did. Okay, so it's 128 by 128. And then we can just say that it's white and that it's 50% transparent. So what we should see, if I got this right, is when we toggle the grid. Let's see. So collision, that is set to 1. Image ID +1, 180. I assume that there's some other problem. Huh, why didn't that render? Render rectangle. Initialize. Oh, because I didn't add it. Oops. That's always helpful. Current context node. Okay, so that was the problem. I didn't add the. Yep, Dagachen, you're absolutely right. I didn't add it. And that's why it didn't render properly. I forgot that that's how that that's how that works. That's what happens when you don't work with this stuff often. Yep, you told me. You were right. Alright, so toggle grid. And now it's rendering it. And let's see what we get. Anything? It looks like it's trying. It's weird that that's not doing anything. Let's just see. Is it not handling the opacity properly? Toggle. It looks like... Oh, you know what? It's drawing a rectangle. It's not filling a rectangle. Which doesn't help me because that's not what I want. How? Tiger Fill. Who is Tiger Fill? Alright, so that's that, and then let's go back and make this, what are you doing? 50% opaque. And I guess, okay, so that's the other thing, is that this has to happen every time. Because this is immediate mode GUI, not a traditional one, so we gotta make sure it does it every time. But that's not really opaque, that's, it is opaque, it's not transparent. So I'm going to assume that what's happening is that Tiger is not doing the fill properly. Let's see. Is it not blending? It's not blending. Okay. So it is going to... This should be interesting. So, excuse me while I hack some color blending together. So what I need to do is I need to, so basically we want to average the color together. Color.r times, well, we don't, it's not average, we want to use the opacity to determine how much of one color versus the other we actually need to use. So let's do this. So that gives us that, and then from image equals color, a the other problem with this approach may be, well, no, actually, I think if we do this right, it shouldn't matter. I was going to say the other problem is that it may end up causing a problem where it's not rendering the blend properly, but that would, I think that's going to be okay. We'll see. Because we're essentially redrawing every frame, that shouldn't be an issue. So we have our from color and our from image, and then what we want to do is we want to say, okay, CR is color r.r times from color, which I guess we can pre-calculate that, can't we? So we don't have to redo this every time. And I bear in mind, I don't even know if this is the right approach to be taking, but this should be okay. If it turns out it looks wrong, I'll research proper color blending. I remember there's an episode of Handmade Hero where Casey did this for stuff that he was rendering in his software implementation of the renderer, and he did it in a more optimal way where, well, first he was doing it in software, but then he ended up doing some intrinsics with vector alpha blending, and that worked obviously much faster, but I'm not gonna go there. So let's see, so this is pix TD is the current value, actually. So what we want to do is we want to take that. Oh man, is that's not even in RGB. It's just an int. So now we have to shift this. Okay. Shift by 6. If it's RGB, that's 2 and 4. No, by 4. TD, what's the matter? Oh no, it is. It is okay. Why didn't it? Is it a pointer? Times from image. This then. So basically the idea is the opacity is telling us what percentage of the original color we want versus the color that we're using to draw. So if the color had an opacity or an alpha of 255, this value would be 1, this would be 0, meaning that this would be our full RGB value that we had before. And when we went to do this calculation, the values we got for RGB would be the full values for color. If we get a value like 128, which is 50%, we'd see that from color is 50% and from image is 50%. And then what we're doing is we're taking, this actually should be this, because we pre-calculated it. We're taking the averaged, or sorry, the proportion of the original color and adding the proportion of the other color, such that you could only possibly get, 255 max, but it is a blending, proportional blending of the colors. So assuming I did that right, what we'll see when I click on the grid is we should see that become, okay, well, not exactly. Let's see, if we go to the gradient toggle, it's becoming gray. Why? So this, let's find out why. I mean, the good thing is that I didn't break everything. Let me make this a conditional breakpoint. Condition is true. Color dot A is not equal to 255. Okay, so A is 127. So from color, can we close this, please? Thank you. So from color, we're taking about 50%. So the R value should be 255. It is. So the recalculated RGB are half the values, so that's good. And then from image, we're taking 50%. So then we go to the point here where we actually are calculating this, and we're taking, let's see, so we're taking the RGB value of that, we're adding that to it, and we're taking this value and multiplying it from image to get a proportion. So let's see. Getting any other values here? Maybe. I mean, we should get something other than just gray. Oh, you know what? It is a pointer, but we should be using the index. Let's see how we do here. Yeah. So now we're getting, yep, so now it's drawing the grid with some, or the value, the white rectangle here, but with some opacity so you can still see the colors. Now that's actually maybe a little bit too opaque still. 132, where are we? No, here. Let's make it a little bit less opaque. And the gradient one is a good one because there's actually something going on in it. Yeah, there we go. Cool. So now let's make this happen for every grid, every part of this grid. So what we want to do is we want to so for I is equal to, or int g is 0, g is less than 16 plus g, and this will be +1 plus g, and then we want to say 1 shifted by g, and then let's see, so this is the x and the y, and we want to, well, should we use x and y then, just to, maybe we'll just use x and y just for the sake of keeping this calculation in the positioning there simpler. x0, x is 4 plus x. And this is x plus y times 4. So if that's a non-zero value, then we do this. We +1 x plus y times 4, and then it's, this is plus x times Let me see. What did I say? The individual ones are 128, so that's shifted by 6. And then plus y times 6. Sorry, shifted 6. They're 128 by 128. Gradient toggle. Oh, slightly off there. What did I mess up? What did I mess up? X plus X. Image ID. X is 0. So let's see if if Y is 1 and so it's Y. Oh, no, that's fine. Y times 128 plus 20. I did that right? 1, and then left shift. 1, 2, 3, 4, 5, 6, 7. Oh. Well, that explains it. There we go. So now we can toggle this. We save it. Go back. Toggle the grid. And our collision comes back. That is awesome. So now, if we have a metatile where only a section of it is collidable, we do that, we save it, and now when we come back and toggle the grid again, we have our collision area masked. Nice. Okay. What time is it? I'm going to wrap up here because that's actually some good progress. We've got our metatiles saving and dealing with the collision information now properly, and we can on Monday start to look at how in the map we will look at that information and use it to determine what's actually kind of cool about this is I'm trying to think if there's so what we can do is we can now save off that information in addition to the metatile information that we have here along with the map, or well, it's not going to be in the map, but it'll be additional information we save off, so that now when we are looking at the map, in here we can even maybe have a mode where we can see what are the collidable tiles, and then from there implement in the game will store off the additional metadata, or the additional metadata about these metatiles, and so whether or not they're collidable, and then the 2 bytes about what which of the 4x4 set of tiles is actually collidable, and then we have to essentially use the player's position to do the calculation we want to find out if they're colliding with the with the position, with the metatile, and then with the subtiles in there, and appropriately destroy the ship. I think that's going to require us doing a little bit of reworking in terms of the player, because right now the player, we're not doing any sort of calculation of the player's position in world space. So right now the only position we have for the player is the ship position on the screen here, so we know where the player is obviously on screen here, and we're setting the sprite position. But we need a world position, because that's going to allow us to look up the player's position on this map to determine where, over what tiles the ship is being rendered or flying over, or whatever you want to think, however you want to think about it. And then use that to then calculate whether or not the ship is colliding, and then have the ship blow up as a result. And what I'll do, I mean, it's not going to be anything, not that my current metatiles are so fancy, but I'll have something pretty basic that just will act as a non sort of background metatile that you can collide with, and then we'll use that as our sort of test. So maybe what we'll do is we'll change the map up a little bit so that we have some, I really want to have some sort of, like sort of just background tile that's pretty basic, but like looks decent, and then have some obstacles you have to fly through in order to continue up, scrolling up on the map. So yeah, that's what we'll do on Monday. But the asset tool is ready for that. It's got the information. It's not exporting it yet, but I think we need to I need to think about how the best way to do that will be, and how we want to export that into our existing files that we're exporting for the metatiles. So there may be some additional information we'll include now separately. I wouldn't want to do it in the actual metatile information, only because it works to our benefit to keep it as a 16-byte array that we're storing out right now, because then indexing into it is really simple, because you just do the 16, you do the multiply by 16 by just shifting by 4. If we add additional bytes into it where we end up not having a power of 2, then it adds more calculation work unnecessarily. So yeah, thank you for watching. A little bit of a shorter stream than my typical marathons, but some good progress, and not working on the name tables and the attributes this time, which is good. I'm just getting a little bit sick of having to figure that out, but yeah, Monday we'll work on the collision. And as always, if you have any questions, feel free to tweet me on Twitter at Clairvis. I have these recordings posted on YouTube. I'm on the Nintendo Age Discord. A few people have joined the Discord after watching the stream. I don't know if they were lurking on the stream and decided to join because of that, or if it was kind of a secondary thing, but it's cool to see people who have been watching the live streams on there. So definitely do join. Great bunch of people on there. A lot of interest in NES programming, especially with NES Maker being a thing. But yeah, so if you have any questions, reach out, and I'll see you Monday, and have a great weekend.